Okay, so how we define center of mass? What is center of mass? See, for any object, remember that for any object, particularly, let's talk about the simple object, right? Let's talk about a very simple object. You must have observed this one. Like suppose we have a table and you are keeping your book on side, right? Suppose you are keeping the book on the side. So sometimes the book is not falling, right? It's a practical observation. But after crossing a particular point, this point basically, right? This point we name basically as a center of mass. If the book is kept in such a way that center of mass is beyond, it is here, that is, it is crossing this line, which is the edge of the table, this book will fall, right? So you can see this observation for any object. If any object is there, center of mass is basically within this edge of the table, this will not fall, okay? Otherwise, it will fall. So what is center of mass? So center of mass is basically the hypothetical point. Remember, it's a hypothetical point, not a real point, at which the entire mass of the object is supposed to be concentrated. Okay, it's a hypothetical point, not a real point. It means to explain certain phenomena in physics, we are using center of mass concept. Okay, now let's see some visuals also, which will make you understand better that how the center of mass and this entire thing is related. Remember, this is coming under the topic system of particles, in which the first step is center of mass. To understand center of mass, how the center of mass is working and everything. Okay, so before that, what is a rigid body? Can anyone tell what is a rigid body? I will give the option of unmuting. You can unmute and you can interact also, no problem. So what is a rigid body? What do we say in physics? Remember the rigid body. What is meaning of that? Anyone knows about rigid body?
Sir, electric body?
Yeah, what is a rigid body?
Intact, sir, like joint body.
No, okay. Suppose we take one glass and we fill glass with water, right? Will it be a rigid body? Will it be a rigid body? So the answer is no. Why it will not be a rigid body? Because if you'll start moving this glass here and there, then the water will start moving from one point to another. Then the distance between the 2 points will not be constant. So rigid body, remember, what is rigid body? Rigid body is all those bodies for which distance between any 2 point, distance between any 2 point will be constant. Okay, distance between any 2 point will be constant. So any 2 point we take it. Suppose we are taking point P1, we are taking point P2. Similarly, we can take point P3 here, point P4 here, right? So distance between any point will be constant during the motion, after the motion, before the motion. So there should be no change between the distance of the point. So that is rigid body. Okay. In the entire, remember, system of particle or rotational dynamics topic, we will assume that object is a rigid body. That is a precondition for this topic to discuss. Okay. So that is what it is shown in this visuals also. Okay. Distance separation between any two adjacent point, any 2 point will not change by application of any external force or during motion or anything. Distance must be constant. Okay. If the distance is constant, what will be constant? Size will be constant. Shape will be constant. That is what it is exactly. So this is the rigid body. Okay. So any application of the forces or any movement of the object, it should not change the shape and size of the object, and shape and size will not change provided distance between 2 point is not changing. So this is the rigid body. So rigid body is that which does not change its shape or size after application of the forces. Okay. There is no perfect rigid body. Because why we are saying there is no perfect rigid body? Can anyone answer it? Why we are saying that there is no perfect rigid body?
Sir, after certain force, any body will change its
Very
shape.
good, very good, very good answer, Shri. After a certain force, right, every object can be broken, every object can have a distance change and all those things. So we are not talking about very high forces. We are talking about the forces which is not very high. We are talking about the forces which is normally applied on the object, right? In that case, we are talking about rigid body. Okay, so rigid body is not necessarily any object perfect rigid body, because application of force matters, but general discussion, like let's talk about fan, right? Let's talk about fan. Can we say it is a rigid body? Will the distance is changing? Try to understand. It is rotating, right? It is rotating. See the fan in your house also. It's rotating. Will the distance between 2 points will be constant or changing here? Tell me. Just observe it.
Sir,
Will it
with
be
respect to what it will be changed, with respect to weight, it will be the same constant, sir.
no? Will it be constant or changing, Shri? One word. Constant or changing? Will it be rigid body? A fan is a rigid body or not?
Yes, sir, it is rigid body.
Yes, very good. Yes. Why it is a rigid body? Because it is rotating. That is correct. But every part is rotating. It's not that one part is constant, other part is not. So distance between this one, particularly we are talking about, try to understand the part which is as a fan rotation, not the fixed part, ceiling and all those things. We are not talking about that one. Together, if you'll take, yes, it is not a rigid, but the part which is rotating, which is used as a fan, yes, distance between them is always constant. Like the 2 points on the blade, or between two blades, distance is constant, or this one. So we'll say it is a rigid body. Okay. Ceiling fan is a rigid body. What about this one? Will it be rigid body? Think carefully. Will it be a rigid body?
No, sir.
Why?
Sir,
What is
because
what else will it be rigid body? Yeah, tell me. Will it be rigid body?
yes, sir.
Distance. What happens to the distance there?
Sir, it is
If
constant, sir. The
distance is constant, or the when he's going to add this one, the particle which is already there, they are rotating, right? They are changing the shape also. If shape is constant, remember the other criteria for checking is what? Shape and size we can see. Will the shape and size change as the potter's wheel is rotating? What is the answer for it? Yes, it will change. So we cannot claim it. If shape is constant, then we'll say it is rigid body. So the criteria is it should not change. Now this one, inclined plane, object is moving down the inclined plane, right? The block is a rigid body. Even if it is moving, see, movement has nothing to do with this one, right? And what type of motion? It is translational motion without any rotation. So it can have translational motion as well as it can have rotational motion also. So this is a translational motion. It is motion down the inclined plane in such all the particles of the body are moving together. They have the same velocity at any instant of time. Okay, this is translational velocity. What happens in a translational velocity? That also you should understand. If any object is moving, right? Like here, block. Let's analyze the block, different points of the block. This is a point P1 of the block. This is a point P2 of the block. This point P3 of the block. This point P4 of the block, right? If the block is moving with, let's take 10 meter per second, right? And let's take acceleration also is 5 meter per second square. How it is there, that is not our concern for the time being, that what force is making it and all those things. Okay. So now, if it is having 10 meter per second velocity and acceleration is 5 meter per second square, what will be the acceleration of P1 point? Tell me. We are saying it is a rigid body. What will be acceleration of P1 point? How much it will be?
sir,
Can
5
you?
seconds square.
Yes, very good. P1 point velocity will be 10 meter per second. What will be acceleration? 5 meter per second square. What about P2? What about P2? What will be acceleration for this? What
Same,
will velocity for this?
same,
Same 10 meter per second?
Yes,
Same
sir.
acceleration 5 meter per second. So in fact, the entire discussion of talking about the rigid body is when rigid body is having a translational motion. Remember that. Translational motion. When a rigid body is having translational motion or translatory motion, then each and every point will have the same velocity and same acceleration. In translational motion, remember, we are not talking about rotation. We are going to discuss that. We are talking about translational motion. So translational motion identification is this also, that each and every point is moving with same constant velocity, same constant acceleration. If it is a rigid body, this condition will be fulfilled always. And that is what basically we are talking about rigid body. If it is not a rigid body, even translational motion can have a different velocity, different acceleration at different point. Okay. Because distance between them can change. That's the main logic. Now let's talk about the next part of it.